Lauren and Sophia were at camp together. They decided they wanted to go on a kayaking trip around the San Juans.
Hey Sophia, I have an idea.
What's that, Lauren?
We should go on a kayaking trip around the San Juan Islands.
That sounds great.
Let's prepare.
Where are we gonna go?
Let's go to Blind Island, but first we need to plan how we're going to cross the channel to get there with the currents pushing us.
Oh hey, I think we can use vectors from our math class.
That's a really smart idea. Let's go!
Firstly, let's go over exactly what vectors are. The definition is a quantity having magnitude and direction. Vectors are used for problems with two forces. Some examples are an ocean current or the movement of a boat. The way we will use vectors in our kayaking problem is to find where the ocean current will push us to, the distance/angle the current will push us, how long it will take to cross the channel, and where we need to aim to reach our point. When looking at a map, we know our starting point and destination, as well as that there is 100 meters or 1 kilometer between those 2 points. We also know that we, the kayakers, are moving 4 meters per second and the current is moving 2 meters per second. This is all the information we need to calculate how to reach our destination, Blind Island.
Okay, so the first thing we're going to figure out is the time that it'll take to cross the channel. We know the formula time equals distance over speed, so we're going to apply this to our situation. In our situation, the distance of the channel was about 1,000 meters, and the speed we were kayaking at was 4 meters per second, so our formula is going to be t equals 1,000 over 4. We know that 1,000 divided by 4 is 250, so it gives us the time, which is 250 seconds that it'll take to cross the channel. That's equal to about 4.17 minutes. For the second part of our problem, we're going to figure out the angle that the current will push us towards the island. In this situation, we're going to start to use trigonometry with our vectors. We know that we are traveling at 4 meters per second while we are kayaking, but the current is also pushing us 2 meters per second west. We want to find the angle that the current and our kayaking will push us towards the island, which is x in this situation. We're going to use tangent because it's opposite over adjacent. So we have 2 and 4. So we're going to have tan of x is equal to opposite over adjacent. And in this scenario, it's going to be 2 over 4. And we're going to do the inverse of 2 over 4 in order to get 26.6 degrees. The third thing we're going to figure out with this problem is the distance the current will push us towards the island. In this situation, we know the formula distance equals speed times time. With this scenario, the speed of the current is what we will be using, which is 2 meters per second, and we figured out earlier on that the time is 250 seconds to cross the channel. We'll multiply 2 times 250 to get 500 meters, which is the distance that the current will push us while we kayak towards Blind Island. So this shows us that basically, if we're crossing the current, or the channel, that's 1,000 meters to Blind Island, we have figured out that the angle the current will push us is 26.6 degrees to the right while we're kayaking. In conclusion, vectors have taught us that we must aim 26.6 degrees to the left if we're kayaking towards the island, or 500 meters to the left, to reach our point with the force of the current.
Using the math Sophia and Lauren calculated that was previously walked through, Sophia and Lauren kayaked to their destination, Blind Island, and the trip was successful.